Good evening, everyone. My name is Ariel Moskovich, and today I'm going to talk about Kafka Rebalance. I'm going to dive into different aspects of rebalancing a production cluster that is under high throughputs and have a lot of data. So I hope it will be interesting for all of you. So thank you for joining. So in today's agenda, I'm going to give you some context, talking about Kafka at Wix, a quick refresher for Kafka terms that I'm going to use during this talk. A little bit about the problem. What is the problem that I'm trying to solve here? What was the motivation to solve this problem? When we are talking about Kafka rebalance, what are we actually balancing? What are the different balance verticals that's included in that process? What are the stages of for this balance? How the results look like? And how we are going to test those results. So that's me. At the last year, I'm working as a system architect at Wix. My 4 last roles, I'm working on a high-scale web companies, and in my 2 last roles, I'm doing Kafka intensively. So I guess we all share the same enthusiasm about Kafka. And this is my first meetup in pajama, doing it in pajama. So that's a new one for me as well. I don't know if it's upgrade or downgrade, but it is what it is. So at Wix, we have several types of clusters. So first, we have our production cluster, which we are producing and consuming to them locally in each of our regions. Those clusters are running on the right throughputs and have a lot of topics, around 15K, tens of terabytes of storage. If we will include the other flavors, we probably will get into hundreds of terabytes. And we also enabling to replicate the data between region by a tooling that was created by our server guild. But basically, we are producing and consuming to those clusters locally. And we're also using Kafka for stream with Debezium to ingest our websites, events into our BI system, and also as a middleware for our logs. So before we start, if you are planning and you are find this process valuable for you, and you are using Confluent Enterprise Platform, I want you to know so you already have tooling that is ready for you. If you're using older version, there is the Confluent Rebalancer tool. And if you're using newer version, they have some kind of a self-balancing cluster. And the concepts that they are using for those tools is very similar to what's the concept that I used in my process. But it's a process and it's also very interesting to know what happened behind the hood. But basically, if you do need it and you are using the enterprise version, you have those tools ready for you as a note. Okay, so quick refresher. So Kafka cluster stores the events, the messages into categories called topics. If you do it right, you are placing different messages, different message types into different topics. The cluster itself consists obviously from servers. Those servers are called brokers. Each topic maintains a partition log, and the concurrency of a topic defined by the number of partitions for that topic. So also, each one of the partition is being populated by one broker or more. So if, for example, we're running in a topic with a replication factor of 1, this partition will be populated by one partition. If we look in the example below, sorry, at the right, we can see an example for a topic. So partition 0 in that case is being populated by broker IDs 0, 3, and 2. Partition 1 by broker 2, 1, and 4, and so on. So it's, and each one of those partitions is a file as a node. So if a topic is, if a broker is participating in more partition, obviously in the cluster, there will be more utilizations that this, or more work that this broker will needs to do, because it participating in more partition, is holding more files, more data is being produced to it, more data is being replicated to it, and so on. So it's important to keep that in balance. We will talk about this in a second. Also, those broker replica regarding two terms called ISR, in-sync replica, which means that one of those broker act as leader. The producing of the client is done to that leader, and the leader is replicating the data to the other broker in this ISR. So it's extra loads on that leader. So it's also an important to balance the leadership of brokers inside the clusters. Okay, so so what is the problem statement? What are we trying to solve here? So when we have a cluster that is in production and is have high throughputs, and we want to increase it and to add more capacity to it, by definition, if we will add more load to it, that's we want to minimize the extra load that we will involve in that process in order to not push it down the cliff. So we want to be able to expand the capacity to this cluster with a minimum interference to the producers and consumers. If we will do it too aggressively, the producer might experience errors. We will have error to produce to this cluster, and the consumer might get into lags in the consume. So we want to avoid that. And when you are approaching this problem, we can do it in a simplistic way when we are taking a structure of a topic that is being divided into partition and into broker, and then when we're adding extra capacity to that cluster, when I'm saying extra capacity, I mean we are adding new brokers to that cluster without assigning any partition to it, without assigning it those brokers to be leader. Those brokers are not going to do any work. So if we will take one topic and we will just reshuffle the new brokers and we'll create a new structure of this topic with the new brokers, eventually what will happen that this topic will statistically distribute or balance the partition count and leadership better than before on that topic. The problem with that will also cause a lot of data movement in the cluster, because then we need to move pretty much start moving from data from any broker to any broker. And that can cause, of course, very high CPU utilization, network saturation, and errors to producing and lags in consuming. So we want to avoid that. What we do want to do is to minimize this data movement as possible. And how we can do that is by calculating the minimum changes that we need to do in each of our topics in the cluster in order to achieve the same goal or the same balance. So what are the different things that we want to balance in the cluster? So first, as I said before, we want to make sure that the partition per broker, the partition count per broker will be balanced. If we have, for example, cluster with 10,000 of partitions and each broker is holding, let's say, 1,000 of partition, this is pretty much a balanced state. But we have brokers that's holding 200 partition and other that holding 800 partition and so on. This will create a scenario when some brokers will do more work than the others, will hold more data than the others, we will produce to them more, we will consume more from them, we will replicate more data to them. So this will cause an unbalanced cluster. So we want to make sure that the partition count per broker will be very close between the brokers. Another factor is the leadership. Like I said, brokers or clients are producing to the leaders in each one of the partitions. If there is unbalanced states and there are brokers that have significantly higher leadership count than others, what will happen that they will be more, they will be saturated because you will also produce or the produce load will be minimized to just few brokers and also because they are responsible of replicating this data to the replicas, and this data need to be copied from them to the replicas, then that they can get into a situation of network saturation because they will also have more network from the clients and more between them and the replicas, which will cause them to be saturated. And this can cause a cascadic failure in the cluster because you will have brokers that are being saturated and then other brokers won't be able to communicate with them and so on. So that's something that is important to balance. And another thing that is a little bit tricky, maybe trickier than the others, is disk capacity. And the reason that is tricky, it's because not all topics are born equal. There are topics that have higher attention than others. There are topics that have higher throughput. And you can have a perfect balanced cluster regarding to number of partition and leadership, but still have brokers with 80% of disk capacity and others with 20%. So in order to avoid those kind of situation, what you need to make sure that specific brokers or a specific broker won't have too many appearances in one topic. So we want to spread it to have good diversity of brokers inside each one of the topics. And another thing that can cause that, let's say, if, for example, but this is more like from the creation topic aspect, is if you will create a topic with small number of partitions, So for example, if you will create a topic with one partition and replication factor of 2, what will happen is this, all the data will be written to only 2 brokers. Now, if you are setting this topic with a very high retention, this data will be written to only those 2 brokers and will be accumulated there. So that's something that it's important to validate when you are creating the topics. So what are the rebalance steps? What are the steps that I use in that process? Now, before I will speak about those steps, I want to give a quick description of how the Kafka rebalance being performed. So basically, Kafka has a tool called Kafka Reassign Partition. And this tool is using a JSON file to describe the topic or topic structure that we want to balance. In my process, I created a JSON file per topic. And this is a very simple JSON file. What you describe inside it is give you a list of hashes for the partitions, which will include the data, what is the topic name, what is the partition number, and what are the replicas, which brokers are populating each one of the partitions. Now, for example, in the example that we have in these slides, partition number 4 for topic hello Hemby topic is being populated by replicas 17, 19, and 45. Partition number 5 by brokers 45, 18, and 0. If I will take this JSON file, and let's say that this JSON file is represent the truly status of that topic in the cluster. And we'll change for partition 4, for example, broker 17 with broker 10. What will happen? That, and we'll use the reassign tool to execute this reassignment JSON file. What will happen? The data will start copying from broker number ID 17 to broker number 10. And when this process will finish and the new broker will be completely async, the new replica of partition number 4 will be 10, 19, 45. Of course, I can do this to multiple partition and create more or to create this process for multiple partitions in concurrency. There is another parameter for throttling that can be used for that in order to do this in a throttle way and not creating and control the amount of data that will move between the brokers. So the steps include, the first step in that process will be to create the original JSON file. And those original JSON files are the files that describe the status of the topics or the structure of the topics as they are before the rebalance. We then taking those original files and extracting some data from them that will help us to calculate and to calculate what are the minimum movements that I need to do for each topic in order to get into the balance state. And then I will in that process also will create the migration file. The migration file are JSON file for each topic that will represent the desired state for each topic, okay? And after I will have those two sets of files, I will run the test to validate this process. And if everything is passed, I will use those files in order to do the rebalance. This is the configuration of this process. This configuration representing first the base directory where I will create both the original files and the migration files. Also the paths that I need to use in order to get this information from Zookeeper. State file and other parameters are unbalanced ratio, which I'm using, and we'll see it in a couple of slides, to calculate which brokers are underbalanced regarding to partitions, and maximum diff that I'm using for our testing. So in order to collect the data, I'm connecting into Zookeeper. And in that process, I will get all the topics, all the brokers for that cluster, create the directories, create the state file. That's the state file including the topic list and the broker list. And then I will go run over the topics and we'll create the original file for each one of the topics. Now I'm going to check that if that file already exists or not. And the reason is because if this process will break in the middle because some network error or disconnection from Zookeeper or whatever reason, I can continue from the same point and don't have to start all over again. After creating those files, what I'm doing is I'm collecting some data that I will use later in the rebalance process. How many partitions I have per broker, per broker and per topic, and the replication factor. And after I have all this data that I need per topic, I will calculate what are the partition or what's the number of changes that I need to do per topic in order to get into the balance state. So how do I calculate that? What do I do? So first I'm calculating the broker fraction of the new brokers. So I'm taking the brokers that I detected, and I will show how I detect that or how I define that more accurately in the next slide. But I will take those brokers, the new brokers, the one with low or none partition assigned to them, and divide that with the total number of brokers. Then I will calculate the number of broker appearance in that cluster. I will take the partition count for that topic and will multiply it with the replication factor. And then I will multiply the broker fraction with that number. So for example, let's say that I have a topic with 30 partitions and I have this cluster include 10 brokers, that one of them is new. So what I will have from the broker fraction is 1 divided by 10. This will give me 0.1. And in the number of broker appearance for that topic will be 30 multiplied by 3, that will be 90. And the number of changes or number of partitions that I will need to change for that topic will be 90 multiplied by 0.1. So total of 9 changes. Now, important to say that this will be, I'm making only 1 change per partition. So from the potentially of doing reshuffle of having 90 changes, if I'm just scrambling everything around, I'm only doing tenth of those changes, meaning much or significantly less data movements in this rebalance process. So I'll define the unbalanced broker. Basically, I'm calculating the median for the partition count for the brokers. Then I'm checking if the broker that specific, I'm running over the broker and I check for each broker if the partition count is less than the median divided by the unbalanced ratio. In that case, the default 2. And if it does, it will considered as broker that we can add more partition into it. It will be under-replicated broker. And in the replacement method itself, what I'm doing is first remove the broker with the highest count. And those brokers, both the one with the highest count and the one with the lower count, are being, obviously, I'm sorting that list continuously in this process in order to update it. Also, I'm reshuffling or rotating that list in order to create balance between both the brokers that I'm removing load from and the brokers that I'm adding load to them. So I will first remove the broker with the highest count. I will add the broker with the lowest count in 2 different manners. One of them, if this broker, and this is something that is important to understand. So in a replica that representing a partition, the broker that reside in index 0 is the one that will be considered by default as the leader of this ISR. So if I found that this broker is leadership count is higher or lower than the one that currently resides in that position, according to that, I'll either insert it to that position or just add it to the replica list. And then I will just update the counters, we'll remove the one from the highest broker, we'll increase one for the lowest broker, and we'll update the replica's counter. So how the results will look like. So basically, at the end of this process, what I will get 2 directories and 2 state files. The state file are the brokers and the topics, the one that I've mentioned before, and the migrated and original directories will include all the JSON file that's in the original. We will have all the topics before or as the cluster is the state of the cluster before the rebalance, and the migrated is the desired set. I am expecting to have obviously the same number of files because this process is running over all of the topics. And if we will focus or zoom into a specific section of specific file, we can see here diff between 2 partitions of workflow events topic. And we can see that in partition number 3, we replaced broker 24, ID 24 with broker 35. In partition 28, we replaced 7 with 27. So basically, if I will apply that JSON, it will start doing the data movement, we start rebalancing or move the data from broker with higher partition counts to one with lower partition count. So we have the files, then basically what we need to do is run over them, and this process could take a long time. It's defined, depends on how your cluster is busy and how you can space this process. Obviously, we do it sequential between topics. We don't. You can have one rebalance process at a time, and we try to, like I said, doing it with the total parameter and do it over time, so we won't overload the cluster. So this is the process of us adding new brokers And this graph represents the partition count. So we can see that there are new brokers that being added to the cluster, and they are starting to, while we're running this process, get more partitions that they are participating. And the veterans brokers are being reduced. So we are removing load from those and heading to the new ones. This is another graph for the leadership count. And what we can see here is dual operation, actually. Before even heading the broker, we have unbalanced state before according to leadership. So what we did is both adding more brokers and also rebalance the leadership count to the veterans broker as well. So we ended up with much more balanced states from the veterans and for the new brokers regarding to leadership. Okay, so after having those files, we also want to run some tests upon them. So the first one is to test that we are not exceeding the maximum change that we defined as allowed per topic. We're changing that the topics are actually balanced, comparing just checking the partition count, testing that the leadership is balanced, checking that there are brokers, that there are no root brokers that are not included in the state file, checking that the topic click is not, and some generic checks that unit test we just running. And this is a screenshot of one of the outputs of the check. So we're checking the deviation from the medians for each brokers regarding to partition count. And we can see they are pretty close to the median. The deviation is relatively very low. And obviously, if it's swamped, it will fail. And then we need to check why and not apply those JSON into the cluster. I want to thank you for listening.